Hi, everyone. Welcome to another episode of the Common Lisp Study Group. I'm your host, Ram Vedam with Atlanta Functional Programming. Last couple of weeks, we've been dealing with updating the cl-neo4j library to use the new HTTP API that was introduced in Neo4j as part of Neo4j and today we'll be continuing that discussion. Last time we noticed that in Neo4j there is something called def Neo4j function, a macro that ends up generating the actual HTTP request that essentially communicates with Neo4j through the HTTP API and executes the appropriate post commands to create nodes and such that. And we realized through our discovery that the actual Neo4j HTTP request was getting incorrectly generated. I since done some digging. I thought I needed to reach out to the actual project owner, but it looks like this was a little bit more straightforward than I thought. It was a misunderstanding of some of the stuff that was written that I was able to make some progress on that I thought I'd share with you today. And hopefully, during today's discussion, we can actually get a wrapper function working to create nodes and such like that, and then implement the rest of our basic functions so we could start writing some real queries against Neo4j. Um, to begin with, I thought I would start with this actual macro definition that we kind of discovered last time. This one is actually generating the given function. Think of it like a convenient way of doing a def fun. In this case, it'll create a def fund for you called whatever name that you passed in. It takes in a lambda list, generates the URI from the URI spec that was provided inside the macro, and it'll take the appropriate payload through an anaphoric macro, encode it, and return a make neo4j request, which ultimately is the physical request that will end up being executed to uh, via the HTTP library Drachma. Um, make neo4j request in turn is a actual function that calls the handle request itself, and um, it takes the structure that was generated here, the neo4j request that we created with the method URI and payload, and the basic implementation of handle requests is the one that does all the meat of calling out to the actual function. Um, here's the specific thing. It'll actually call out the send request based on the specific type of handler you're writing, and it will call out to Drachma with the appropriate uh, method types and things to ultimately communicate with Neo4j to insert or do whatever execution of the given query that you provided into the Neo4j query engine to provide you a proper response. This is all kind of basic review. The one thing to note is, and the best thing to way to illustrate this one thing is to look at one of the other examples of uh, that was provided in the old API that the author wrote, and that is, I think the best one is, oh sorry, not request, best API. Um, and folks who are on the YouTube live stream, by all means, please let me know via the chat if the font needs to be increased or not. I will go ahead and update accordingly. I think from my viewing of various previous episodes, I have the settings kind of perfected now. But by all means, let me know either in the comments or in the live stream itself, and I'll accordingly update. So how this is getting generated could probably be best illustrated with one of these other examples. If we macro expand this, we saw this last time, it actually generates the get node with if node URI, it will generate the actual node ID in a part of the actual HTTP URI itself before it will actually create the make neo4j request with the given payload. Now, the one thing to note is this here doesn't give us the entire information for node creation. A better example of node creation, which is what we were trying to accomplish last week, is this post example here. And the main thing to note is two things. One is not just the URI spec being, a small, minuscule support of the format, but additionally the encode piece, which is something that was missing in our function last week, which I have since corrected, and I'll show you the corrected version of this. But then I hit another snag that I thought I would also show at the same time. The encode, what it does is behind the scenes, it actually ends up calling the appropriate def method structure that the author created to create the appropriate JSON encoding of the given properties. Now, so architecturally, what it looks like this Neo4j library is done is the author has created a proper RESTful API for each individual type of node to match with the REST API that was provided by Neo4j. And what he's done is he used def generic to actually create a encode JSON payload function for each specific type to encode into the appropriate cipher query structure that we encountered. Whereas in the version of the library that I was structuring with just basic Lisp functions, that structure of the statements followed by the statement, the actual cipher query structure was more explicit. In the API, this is a more Lispier wrapper in the sense that now you're only dealing with the Neo4j objects, unaware of the actual payload structure when you are passing in information, which allows users to only concentrate on just node relationships and so forth. However, that being said, given that the new HTTP API focuses on transactions um, with nodes and stuff, we would have to update this wrapper so that we could still maintain the illusion that you are dealing with just nodes relationships and the appropriate queries. But behind the scenes, we would have to convert them into the appropriate transaction, well, cipher query equivalents prior to actually generating the request and sent to the HTTP API. What's interesting is we can leverage this current architecture to at least get us most of the way there. And I'll give you kind of an example of this with our transaction that we were trying to create last time. So what I've done is in our transaction example, I have created essentially. So I moved Cipher Transaction, as many of you know, out into the base library, since I thought it would be much more useful to actually have this inside there. I've created two convenience functions here that hopefully will not leak out into the other aspects of the library. But then I leveraged it like we did before, and I now am encoding a proper Cipher transaction here um, with the create node query as we were expecting. Now, this actually ends up generating what we're sort of expecting in terms of communicating with the Neo4j API. However, when we try running this guy, and this is where, hold on one second. I think I restarted my REPL earlier and I forgot to. JSON is defined but not used. Okay, this is Yeah, this is fine. Let me see if I can run our simple example. If we try increasing this and hit enter, we get a 401 on standard commit. Okay, this is kind of what we end up seeing when we try to execute this function. Now, I did some debugging on this by using Drachma's header stream output, and if we look at the actual URI that's and passed over, we see kind of the indicator what this is, which is we're automatically attaching the DB postfix to the specific nodes, and this makes sense because originally in the RESTful API, everything was attached with DB data. Nowadays, this can be fixed over to using something else. It's using tx/commit. As if you recall, when we, to show you again, when we run our thing, we could see that what this is actually creating is for transactions is database name /tx. All right. And so we're going to have to essentially figure out a way to update the basic structure of what they call, what the author calls format cl-neo4j query that takes in a postfix. We need to change that in such a way and update the infrastructure in such a way that the default is still stayed the same for the older API, but with the newer ones, we can end up just passing in as a code our uh, database transaction URL in this form. Okay, so that's what we're going to be concentrating on today a little bit. And in the meantime, hopefully for folks who are who have questions, by all means post, them on the chat room. And if you are uh, liking our video content, by all means, just a reminder, please subscribe to the AFP channel to uh, uh, get updates on new videos and new information that's happening while we're going through this. So let's start our some of this exploration. Um, so to go back to what I was saying earlier, we need to go to, I think it was in here. No, it was not in here. It's in utilities. Yeah. So one way of doing this is might be creating something like format, Neo4j TX query, but that really is kind of useless now that I think about it. We could actually end up doing probably the same thing here by just doing this. And this is being used in format node nil. Right. So we just need to write probably an update to one of these functions before we pass in the JSON payload. So let's see, node relationship. Uh, um, okay, so we need to first figure out which one of these formats is getting called when we make this change. And let's see. Okay, one way of doing this is print encoding node URL. Yeah, and actually, let's not do a format. I know this may not be the best way to debug this, but this certainly will get us part of the way there. Okay. And what other places is format neo4j query being used in? Let me go and do that. Grep. Oh wait, why am I using grep? I can use Sylvester for this. M Sly. No, not that. It is. Give me a second here. I have to find the Lisp utility that I need to run. Compile, evaluate, go to. Yeah, G is probably the one that I need to use. No, not this one. Give me a second. This is MH. That's what I need. MH. Who calls is what I need. So this is one. This is one. Go to this one. Okay, so this one is also another place where we need to T making send request. Okay, done. Okay, go here, go to Sly. All right, let's see what happens when I do this. Unknown status nil. Okay, thank you. I appreciate it. Making send request is the problem. Okay. Oh, and before I forget, we're getting a 401. We're not actually getting a 404. We need to actually reset our thing with our credentials. Now I can actually try this. Yeah, that's what I was looking for. And this is where the problem's happening. And in format neo4j, there's a way for us to update this. So request URI already has all the information that we need, but what we need is also, okay, so one way of handling this is by saying that the DB postfix by default is, you can update init arg to give us the DB postfix for the basic handler. I'll make this handler DB postfix, and then we'll say init form. This is just going to be DB data. Sorry, requests, no utilities. Yeah, DB data. And then here in basic handler, we will to key db neo4j database, and then so the db postfix is going to be should be optional. That's the one thing we need to have this as an optional thing. I mean, this is going to work, but I just need to make sure I do the right thing here. It shouldn't be db postfix. Hold on one second. Let me change this to just database. Say db URL. No, db name. Okay, handler db is probably 1, and the default is going to be okay. We do not need to provide this if we're going to use the global data, and we could just use this here, db name db. Okay, and what is this complaining about? Neo4j database undefined. Okay, so I have to go and define this because I forgot that I changed this. And also for full things, we need to go to package now. Package, and okay, so this is there. All right. Okay, so let's go back to what I was changing. There we go. And then here in format query, what is this? Host resource. Okay, so here we won't change the db thing, but we will change the db postfix to being format nil db slash tilde a handler db handler. Handler db accessories handler db. So okay, so now this should appropriately set things up. The only thing is I may have inadvertently broke the old API by doing this, but we can check that later on um, as part of a testing phase with some unit tests anyway. Because there are existing unit tests that I could run against. I just gotta start up an old version of Neo4j to get us started on that request. It's not a big deal. Okay, so let me see if this not found. Let's see what has changed here. Ah, I forgot that. There you go. That is what I was looking at. The only thing now is we have in our function, which is written in transaction, we're using the wrong, oops, sorry. There we go. Wrong status. Just to let you know, this in general is a little disappointing because when you are creating a new node, ideally anytime a post should happen, a 201 created should be happening. This is something you will encounter when you start dealing with HTTP APIs more and more frequently. Some APIs, for whatever reason, they use 200 OK status regardless. But if you're following REST principles, which the old API supposedly did, but the new API doesn't seem to, um, for whatever reason, I don't know if it's because of the fact that the assumption here is a transaction is usually a success or a failure. Either the transaction succeeded and you've created the thing, or it's a failure and it gives you some sort of error message behind it. The architectural reasons behind it is not known for me, but for in general, if you end up seeing this kind of thing and it's not a RESTful API, it will get um, a little frustrating. So the transaction API in general looks like it's going to be leveraging four statuses, response statuses. It's just a status 200 or um, a 400 40x, where whether it couldn't find it unauthorized or what have you. So just keep that in mind. Um, and but it looks like we have our first foray. Let's now check to see, before we get too giddy, that we've actually appropriately created this node. So let me share a new tab, a new, and for folks who are on the Jitsi channel, I'm sorry, for whatever reason, Jitsi doesn't allow me to like have multiple sharing windows. So it's not easy for me to like switch. I have to unshare and share. Um, so, okay, let's do this window Chrome tab. All right, now let's go to our browser. Okay, and let's run a match query. A movie where a dot title equals the matrix, return A. And you see we have the matrix. All right. Now, if you want to see the full details of this, you can see what it's the properties in the property graph. Here, there is a way also to actually look at. There isn't a good way of looking at, say, the properties on this side here. but you could see that it's all available here. All right. And again, folks looking at this, the capitalization of the properties. This is something that is a consequence of, if we go back to our Lisp buffer, this is because we are encoding the cipher query using a associative list and converting the associative list into a JSON object through cl-JSON. It takes the properties of the associative list and capitalizes them as symbol names. That's just how the cl-JSON library ends up creating that. That's not um, a consequence there. So if there is an existing schema that you are trying to encounter, maybe there might be a setting inside cl-JSON for you to be able to make sure that it uses only lowercase, but I don't know. I don't believe so. Like, these are all the JSON output symbols. Real handler, use strict JSON rules. Maybe let's try that and see what happens. And let's do a quick test. JSON encode, JSON make cipher query. Actually, let's just say create node query. The test node type, it's another movie. Node properties, title, the test released. And oh, sorry. I used encode, but I misspelled it. Yeah, it's still a problem with it's a consequence of using the associative list. So there might be easier ways to go and correct this. For right now, though, we'll move forward with this stuff. All right. Let's start writing up our additional stuff. But before we do, it would be useful to kind of see how some of this testing stuff works, just to see if we broke the previous version. So for this, I'm going to stop my latest version of Neo4j. I'm going to create a new volume, say prev storage for the example, and then we're going to start a new version with the old API. Now you can find some of these old stuff by just simply going to Docker Hub and seeing if it has the old versions of Neo4j, and it should. The previous versions should be available for you. You just got to go and find the tags. The latest one being around, I think it's either the 5x API, but it's 4.4 is the latest version of Neo4j. But what we want is, sorry, actually the latest version is actually in the 5x line. It's 5.16. Let's see if it has a 3 API, just so that we can make sure that yes, it does. Okay, so let me just do a quick docker pull neo4j 8535 guest community. Let's see if I can get that going. And in the meantime, let me just do a quick docker volume create 4j prev. Okay. So this is some of the stuff that you'd want to, when you start updating Lisp libraries for different versions, something that you may want to set up. Luckily for us, the author wrote a somewhat comprehensive test suite for the REST API for the previous version. So we just need to start it up with it, and we can get started on looking at it. Just do this, put that there, and let's start. I'm just starting, again, like I said before, what I normally do is I do this stuff behind the scenes. I'm just starting another Docker container here. Just give me just 1 second here. Oh, wait. That's it. So we have cl-neo4j. Okay, good. Let's make sure that it's up and running now. Okay. And okay, good. And if we have what is okay. So we now have the old version of the API going. We could easily confirm that this is the case by just simply going here into a shell, doing a quick curl, and you can see that its data is now available for us. So now let's go ahead and run very quickly, just running some tests against this. Now for us, this is already available for us through cl-neo4j.test. I don't believe I have this loaded into my buffer, but we can certainly do that. Give me a second. Where is eShell? Okay. Nope. I have to probably do this. QL quick load cl-neo4j.test. Okay. neo4j.test. Run all tests. And it looks like they all failed. Wait, 404 not found, 404 not found. Yeah, that's kind of what I expected. The default is, so what I have to do is in making basic handler, I have to make the default data for the database, which is kind of sad, but that's okay. I can do that for the time being. Go to globals. Or actually, let me see if I can do something else. No, that's fine. That's probably the easiest way for the time being for this design, and then we can come up with something better later on. Run that, Shift G. Let's see, unauthorized, nope. Let's see, traversal, neo4j. Hold on. Let me do that. Now I can do this. All right. This one is creating. Okay. It may not be catching. Let's do this. And let's go ahead and run this. Okay, and let's see what happens. Create nodes. Unknown 429. Okay, that's new. Let us. Oh, right. Again, because I restarted my Lisp, I have to change this. cl-neo4j. Now I could do this. There we go. So we got everything running except one test is failing, which is in which test that's failing? Unexpected error. Node not found. This might be an existing failure that is already provided, but we shall see. In the case of my URI, what I need to do, I would have to, let's see if I could do, okay. So right now, as you can see, currently, everything seems to be kind of what we're expecting with this new structure. But if I run, say, this example, tx node not defined, let's see why it's saying that. I compiled this. Oh, sorry, MRS, because I didn't expose tx node. Actually, let me just do this. CL user do okay. There we go. And it's not in the cl-neo4j package. What? What are you talking about? I actually exposed that. Okay, so this is coming from, oh, it's here. Let me see if I do that. I may not be exposing it correctly. This sometimes happens. Okay, So as I expected, because we changed it to deal with the DB data, it's probably not actually updating itself. Let me just do this. Neo4j database to being that, and let's see what happens. Oh, right. It's because I'm currently running the old version of it. I have to set this up so that I can run either or. Um, right. Okay. At least this is what we're expecting now. So we now have what we need to deal with. So in this new API, you now have the ability to switch between the old API and the new API by simply setting the um, DB, the database, the Neo4j database global variable. Well, the def parameter, the global variable that's inside the dynamic variable that's inside the cl-neo4j package. And once you do that, the transaction API equivalent that I created for all the old stuff is now available to you. Now, there's some cleanup that needs to be done throughout this example. All right. One, ideally, we want to be able to have these two different APIs live side by side, but with the same kind of symbols. One way of handling that is obviously creating two separate packages. So, for example, last time we were trying to leverage the what's it the last time we tried to create a actual cl-neo4j transaction package. We now may be able to do that now today. So that way, depending upon whether you call cl neo4j slash transaction colon create node versus cl neo4j colon create node, we'll have two different setups for that. So let's try and do that quick refactoring just before we move on, just so this way we have a cleaner API to start working with, and we can still deal with nodes and relationships without having to worry about whether or not we're in a transaction or not. And as we build up the transaction pieces, we could certainly go ahead and fill out this package to be a complete transaction based version of all of the older APIs. So let's go ahead and first do what we did a few weeks ago. We tried creating a package. We might be able to now do that uh, at this point. So the first thing is first to define the package. And so the way we do that is in package.lisp, we create def package here. And we do cl. Okay, we do cl neo4j transaction. No, sorry. For some reason, my slime keeps thinking that I want to create a SIMD autocomplete thing. I'm not entirely sure why. So here we will load, sorry, cl, no, cl Alexandria, because we need it, and anaphora, because that's what's needed for the okay. And let's export node, create node, get node, and delete node. Okay. For the time being, these are the three that we're going to end up creating. All right, now let's go and switch back to not this one, transaction. We're going to go ahead and say that this is now transaction. Oh, we need to do one more thing, which is in the ASD, we need to include this file, and we would need probably everything up until requests, if I'm not mistaken. Let me just make sure. Yeah, we need to do everything up until requests. So here we will add file transaction, and we say it depends on requests. Okay. And let us go back to the displays and let us get rid of this and add this here, but we're going to rename it. We're going to go ahead and restart our Lisp for the time being so that we can do these changes in isolation in a clean Lisp image. And then we have the ability to test to make sure that everything is doing, and then we can write actual unit tests against this. One thing to note about unit testing this API that I thought I'd mention here, many of you who are used to other languages, unit testing frameworks and structures, at least when it comes to HTTP APIs, are usually used to creating some sort of mock object prior to actually testing, statuses for this to make sure that you have faster tests for execution to make sure application logic specifically gets appropriately handled for the given cases of whether or not you're succeeding or failing a particular operation. Here we're writing system level tests mainly because since we are testing against essentially a database, and we're trying to make sure our API matches what the HTTP API is expecting when passing payloads to that database. It'll become important for us to write such tests where we actually are running a database, a production database, or a database of some sort in the background prior to running these tests. Now, obviously, since I'm using Docker, one might be thinking that there should be a way for us in Lisp to be able to start up the Docker container to then run these tests and then to ultimately delete this Docker container. As of today, some of that infrastructure does not exist. I have been pondering how to actually encounter and kind of correct some of this stuff, especially as we are going through this stuff, because that infrastructure of being able to start and stop containers, especially for testing, becomes very nice, and it's very important when you're ultimately trying to write something that could probably run in like a CI system elsewhere, maybe even the cloud. And if you have those tests available and that infrastructure available, it will then make your life a lot easier. So this way you don't have to kind of assume that you have a running database in the background. It'll just fire up one for you for the lifetime of that test execution. And then you can always go back and decide whether or not you, say delete the database or have it like a running log of things, um, and have the ability to debug when particular queries actually get executed, maybe fail. You can actually stop the container and do stuff like that. That currently, again, does not exist, at least in the common Lisp world. That's some infrastructure that needs to be written. That is something that, again, like I said, I've been pondering and trying to figure out. But for the time being, we are not going to address that, at least not in today's discussion. Um, so let's move on. Let us do this very quickly, which is okay. So let me just go ahead and restart this one more time. Okay, let's do a quick load. cl-neo4j. Hopefully everything passes. And what is it complaining about? Compile file. Let me see what the error is. What? Okay. Let's do that. We need to change something here. We need to essentially make that def neo4j macro into an exported symbol. Okay, let's do that. Okay. I can't just do that, can I? This API has create node. We're going to have to actually separate this if I'm going to end up having to use his additional infrastructure, don't I? Okay, so this refactor is going to take a little bit more time than just doing this. Okay, so just so that we can push on, let's go ahead and change back what I wanted to do here to, okay. Okay, let me try that. Shift G, restart. Looks like that worked, but let's see if that actually works on a clean image. Boom. Okay, so let's do a quick test to make sure cl-neo4j.tests actually passes to with 97% like it did before. Let's do this. Oops, oops, oops. Hold on. Okay. Unexpected failure. Oh, right, because of the fact that since I restarted, I had to go and re-provide my credentials. There we go. Okay, and the only one that's failing is something related to the old API on traverse/node that's unrelated to the work that I've done. Okay, so now we can actually switch over and write a new test for our stuff, and we'll end up using 5 a.m. for this too as well, and then we can get started on writing two other things. Okay. Let's take like quick detour and looking at how some of this test is written and see if we can leverage some of the same kind of infrastructure that he provided. Um, so let's do this. Actual condition 401, whatever. Okay. Let me see this. Clear REPL. Go to not that. Go here to the tests. And let's look at the what's in the main define suites run tests. Okay, so he wrote. Okay, we can leverage this too as well. Def suite cl-neo4j transaction. Okay, now let's do util. Let's see what's in here. With test nodes, he provided a nice way of generating the node. You may not be able to extract this stuff. Okay, let's try REST API. Here we go. Okay, so we still need a little bit more information to do an exact kind of replica of some of these tests. For example, if we look at this test right here, what this is doing is it's grabbing the node ID, which we could certainly grab in our version of the new Neo4j API. The only thing is we need to be careful in that the query itself is going to have to return the ID for us, and then we can actually write a test similar to checking to see that it's a number, it's equal to whatever we retrieve again, and so forth. Um, so that requires a little bit more, obviously some more digging into how we want to kind of define this kind of API. Um, I think I will, for the remaining time of today's discussion, we're going to kind of hash out the nodes and relationship functions themselves, and then we'll focus on kind of being a little bit more robust in testing, um, uh, beginning, probably next time, just merely because the fact that this is probably going to take a little bit more time to actually hash out a proper test harness for testing all of these things, mainly because again, the new API just basically gives you the full node object itself, whereas the previous one they were more isolated in terms of what they were providing because they were more restful components. Um, so let's go ahead and do that instead. Okay, so let's go to this and MRS. Sure that our transactions are there. No class, cl-neo4j cipher query. Oh, apologies. I have to do this. Looks like I'm going to have to expand, sorry, the query data structures. I have to expose them so that we have access to them. Cipher query and cipher transaction. Okay, so now we may have to restart our, well, let me see if I could reload this. Okay, let's do, sorry. Okay. Okay. Let's see if I could do a quick reload of cl-neo4j. Good. Let's see if this works now. URI, variable URI is unbound. What are you talking about? Hold on. Might be easier to do this. This sometimes happens when I reload. Okay. Let's make sure we have our URI. Good. Okay. And let's go to here. Okay. Let's also set f cl-neo4j database to neo4j for our discussion because the old API uses this. Okay. So we loaded our credentials, we loaded our database. Let's go back to this and go into the package, run, and body's unbound. Hold on one second for drachma header stream standard output. Okay. Weird. So what is it complaining about? Body unbound. Okay, so I have to go and look at let's see. What is the actual says the length is made the request and make request is actually not getting the body. It's what it's what it looks like. So let's go ahead and do this. Hmm. Okay, so the only way to test this is to see what is Drachma actually getting when we create the actual request itself. So we need to go back to our Scratch buffer because we already inserted this database before this node before once. So it might be that it's getting a payload that's not getting understood. Let's see. Let's do let's do this. Okay. We're going to go ahead and essentially mimic this, but we're going to do what we would normally do here, which is that. Okay. Oh, right. Let me go to in package cl user. Okay, so now we have what I need. Let's do that. Okay, so now we can do flexi streams octet to string. Syntax error. Here we go. Invalid input. Expected minus the matrix. Movie. So there's a problem in our syntax. So what is the problem? it does look at the create query. Okay. We do this, check query. Ah, that's the problem. Invalid arguments 2. Wait. Ah, okay. I did correct this. There we go. So this is actually still working the way we expect it to. So it's still getting a body, it looks like, and it's just not liking the body. Let me go into here, and let's look at actually the old REST API. Not this one. This one. Status handler's body. So it's weird. Let's see if I can go back here to this. Body is unbound. Why is body unbound? When we created this here, we have to go and Mac. We create. Oh, so since it's an anaphoric macro, this make request neo4j request needs to go in and appropriately get this in the callback. See, we have to pass it in. That's the problem. We're calling cl-neo4j body here, but we're not actually calling cl-neo4j body here. Okay, got it. I have to explicitly call out, sadly here, because it's since it's a macro, we have to explicitly call this unexported symbol. Let's see here. What is style guidelines here? JSON never used. What? It's defined but never used. Hold on. Let's see how this works. Decode JSON. Oh, right. We need to actually also expose that, don't we? Okay. So this is another transaction that we kind of forgot that we need to also occur, which is in the package, we need to also because make neo4j request is already. Actually, that's kind of weird. The macro was able to appropriately say make neo4j request, but it didn't recognize that it needed to expose this one. Let me see if I could do that. I don't like doing this, but this is just so that we can actually see if this actually works the way we expect it to. Okay, so now this is doing what we kind of see. Boom. Okay. At least now we're getting what we want, which is, but now we need to figure out why in one case we're doing a proper macro expansion of all the unexported symbols here. As you see in this macro, we never actually exposed URI, we never actually exposed JSON or this. The macro itself is the only thing that needed to be exposed, and everything else became simple. But this callback here, I don't think it's recognizing that this callback is part of the macro. It's not. It's part of an internal symbol that was actually exposed. So this is a little disconcerting, but that's okay. I think we can manage with this for now, and then at some point there might, as part of the other cleanup that I mentioned before, we can account for or accommodate the situation where this is stuff by moving around some of the symbols into other packages so that things are a little bit more modular than they are today. And that this is essentially a function of the fact that I modularized one part, but I didn't modularize everything. And these symbols are leaking over. All right, so we have one thing here for creation. Hopefully, I didn't accidentally create like 6 of these nodes because we called the same node like 6 times. Should have been smart enough to recognize that I inserted it. Tried to insert this 6 times, but we will see. Oh, that is rather unfortunate. um, huh. Okay. So I'm gonna show this to you, and then with the time remaining, I will. Uh, it'll be. We could leave it at this. I can open the door for questions. Um, I'm gonna show you what just happened through our debugging session. So earlier you saw that I was using the same matrix node function request multiple times within the transaction. Um, but right now, as it stands, and you will see this in a second, if you look at our nodes, you'll notice that every time we created yet a new node. So if we want to have a proper, transaction in terms of an atomic version, like a relational node, like these are all unique. You have to essentially make sure that you've accommodated that in your function, in your actual request. And by doing that, it's basically in a graph database. Graph databases aren't like relational databases, right? Each row doesn't necessarily have to be unique, especially if you didn't put unique constraints on it, right? And in graph databases, there aren't any real, as far as I know, Cypher doesn't provide any sort of way to provide uniqueness constraints on a specific node. just because that's kind of introducing kind of like a schema into the piece. And uh, a schema might have some advantages for uniqueness constraints, making sure that certain rows don't change or you don't have any duplicates specifically. But as you can see here, because we're freeing the structure and dealing with individual cells, you may have in some situations different um, in this case movie objects that have the same name or the same node, but they're represented as different node IDs in the graph. So here it looks like we have 7 instances of, or I think more than 7 instances because I called this multiple times, of the matrix. But if you actually look at each of the IDs, each of them are unique IDs. So these are all individual nodes themselves that have been inserted. It's just that we didn't provide any uniqueness constraints on release title or the node title itself. So what we could do to accommodate this is if we want such a thing is we can add yet an additional query to make sure that the node doesn't exist in the graph before we actually insert it. But that's something that I would want to expand in a different function. That's going to require a little bit more testing to make sure that's available, and a little bit more of a complicated API. But this basic structure is still available to you, and this is something that this freeable structure is very useful for certain types of modeling problems, which we're going to be encountering in the coming weeks. So, with the last 13 minutes of today's discussion, I'm going to open the floor for questions from anybody who's interested in providing anything. Um, but next time, if there aren't any questions, join us next week where we're going to start, deleting nodes, adding relationships, and essentially writing a script that will allow us to, provide some data injected into this and run some queries against this and maybe write a little front end too as well in the coming weeks to complete our project and exploration of graph databases with the Neo4j library. Um, but any questions? Okay. Well, until next time, thank you for joining again. I appreciate you all for being patient with our exploration of this API. And I hope to see you guys next week. Bye.